and we're going to get the pen up here. Look at projectile motion, motion in 2 dimensions. And what we're going to see here is that the x and the y vectors are independent of each other. So what does that mean? It means if you're moving in the x direction, the y direction doesn't really affect anything. Now let's look at that. So we're going to have this motorcycle with a crash test dummy, not a real person, drive off the cliff. So initially, there is direction, there is velocity in the x direction. The y, there doesn't start to be y velocity until gravity kicks in, once the wheels are off the cliff. Now the size of the x speed, the vector for the x velocity I should say, doesn't change. If it was going off at 50 miles an hour, it just keeps going 50 miles an hour in the x direction, but not in the y. The y is going to increase. Now initially there is no y speed, only x. It's going to have a certain y speed when it hits the ground. We're going to calculate that later. And what I think is interesting about this problem is that they only give us 2 numbers. They give us 50 meters and they give us 90 meters. And that's all they give us. So we have to work with one of them. Let's work with the 50 meters first. Let's get the time of flight. And we're going to use, plus the initial t plus 1/2 at squared. We're going to use the position equation. You might say, well, why didn't you use time independent, or why didn't you use definition of acceleration? We don't know any of the other speeds yet. This is really the only one we can use. Oh, and this should be y initial, excuse me. So y is where it finishes up, which is the ground, which is 0, and y initial is 50. This whole second term is 0. It has no initial speed in the y direction. You might be saying, yeah, but it's moving in the x direction. Well, we know that, but not in the y. When we look at the y, that's all we look at. Okay, plus 1/2. Now the acceleration will be gravity, 9.8 t squared. So if we do a little algebra, half of 9.8 is 4.9, and we get 4.9 t squared equals 50. Just multiplied this and moved it over. Now let's divide both sides by 4.9. I think it's pretty easy to see 50 divided by 4.9 is going to be about 10. In fact, you'll hear me, you might even hear my calculator buttons here, 10.2. So t squared is 10.2. Oops, I clicked on the eraser, excuse me. There we go. And then to get t, we just take a square root of both sides, because we don't care about the negative root. That doesn't mean anything for us. So this motorcycle is going to be in the air for 3.19 seconds. All the while that it's in the air, it's moving in the x direction the whole time. Now, how fast must it travel to hit the ground 90 meters from the base of the cliff? There's also no acceleration in the x direction. If we look in the x direction, velocity is distance over time. There's nothing pulling it in the x direction. It just keeps going at the same speed that it came off the cliff. So in the x direction, they told us it went 90 meters in 3.19 seconds. Now 90 divided by 3 would be about 30. That's 3.19. So that's our 28.2 meters per second. I think I can get rid of that. There we go. Sorry, sometimes it's tricky to get the pen back here. There we go. Let me go back a second. It's fine. Sorry about that. But 28.2 meters per second. And it took 3.19 seconds to fall to the ground. Sometimes students will say, well, is that the same time in the x and the y direction, or is it different? If it's in the air 3.19 seconds, it's in the air 3.19 seconds. It cannot be different in the x and the y. let's get the vertical velocity that hits the ground. And I think we'll just use definition of acceleration. V final minus V initial over the time. So this is going to be the vertical velocity at the end, the final one. So let's see. V initial was 0 because when it drove straight off the cliff, it wasn't angled down and it wasn't angled up. So we can get rid of that, and that's going to make our equation much easier. Then we get V final is AT. Just multiply both sides by T. So V final will be negative 9.8, and we said, I believe it was 3.19 seconds. So let's see, 9.8 is about 10, times 3 is about 30. So easily we believe the 31.3, negative 31.3 meters per second. Now we've got to figure out the overall velocity when it hits the ground. That's a little bit trickier. It's not going to hit the ground straight down or straight up. So it's going to be moving at 28.2 meters per second in the x direction, but it's also going to be going down negative 31.3 meters per second. So that motorcycle is actually going to hit and come down at an angle. And this will be a right triangle. So I think hopefully we remember, well, V final squared will be 28.2 squared plus negative 31.3 squared. We're just using Pythagorean theorem. So we do a little math here, and let's see what we get. 28.2 squared plus 31.3 squared is a really big number. 1775. And we'll just take a square root of that. And if everything is like we want, we'll get 42.1 meters per second. Because it's going to come in at that angle at 42.1 meters per second. Now to get the angle, we'll use tangent. Tangent is opposite over adjacent. So the opposite side is 31.3. The adjacent is 28.2. And that's just some number. It's a little bit more than 1. So the tangent of theta is 1.11. To get theta, we need to take the inverse tangent. And it's around 45 because the tangent of 45 is 1. So we say that the theta is 48.0 degrees below the horizontal. And that's not too neat, but you can see what we have there. It's a good idea to circle our answers. Now, why didn't I use south of east there? When you're driving off a cliff, you're not really necessarily going south of east. This cliff could have been facing any other way. So we kind of say, all right, well, if the horizontal, kind of like the x-axis, would be here, if I draw a dotted line, the theta's got to be below. And let's try another one here. So Leonardo the turtle throws a frisbee from a 20-meter hill with a horizontal velocity of 8.6. So the hill is 20 meters. I found this picture, I think I got it online somewhere, and somebody said it looked like, Leonardo the Mutant Ninja Turtle, so that's who we made it. I think it was originally me, but they said it looked more like a turtle, so it doesn't matter. Okay, so let's see what we know and what we want to find out. We know the x speed, and we know the height of the hill. A, or the first part, asks us, well, what's the vertical velocity of the frisbee as it hits the ground? Because as soon as it leaves his hand, it's going to start getting pulled down by gravity. So let's see what we can do here. We're going to use time independent. because we don't know the time of flight yet. We'll find it in a few minutes, but we don't know. We could have done that first, but let's just do this first. Now, in the y direction, we threw the Frisbee at 8.6, straight horizontal. We're only looking in the y direction. It had no initial y velocity. So this is going to make our life a lot easier. So let's see what we got here. Acceleration is v final squared over 2y. So if we move that up, v final squared is 2ay. Now it's pretty easy. Just multiply both sides by 2y there. 2, negative 9.8. Now, it's going to fall 20 meters. That's a pretty tall hill. And I know this is going to be negative. We'll take care of that in a minute. So 2 times 9.8 times 20 is 392. Now, we can't take the square root of a negative number because of I and all that crazy stuff. But remember, for us, the negative doesn't really mean negative. For us, the negative is the direction. So we can kind of safely pull that out. So the v final is negative of the square root of 392. So v final is negative 19.8 meters per second. The horizontal velocity as it hits the ground is what it asks us next. But remember, x and y are independent. There's no acceleration in the x direction. So this is nice. This is just 8.6 meters per second. It does not change. Okay, time of flight. Now that we know that y velocity, we can just use definition of acceleration. If I ever go too fast on these, I apologize. But the nice thing about the video is you can always slide it back or rewatch it if you want to. I'm sure that'll be really exciting for you. But just slide the slider back and watch it again if you need to. Now this is nice because v initial we said was 0. So acceleration is v final over t. T is v final over a. I'm just switching those variables basically. So we now know v final was 19.8, negative 19.8 over gravity. And we can see that's going to be about 2. And it is. So this thing's going to be in the air 2.02 seconds. Now, how far did the Frisbee land from Leonardo? That's an X question, right? Because it's going to be how far did it land from the hill? There's no acceleration in the X direction. So we can get away with v is x over t. X equals vx times t. I believe that was 8.6 times 2.02. And we can now know that it lands, 17.4 meters. That's in the x direction. To get the overall velocity, remember that Frisbee's not going to necessarily land straight. It was going at 8.6 meters per second in the x direction. Then in the y direction, you have to excuse me, I have to take a quick peek here, negative 19.8 meters per second. So the Frisbee's going to angle downward, just like that. We're going to get a v final and a theta. Now to get v final, it'll be Pythagorean theorem. And I'm going to go a little quicker than I did on the last one because we've seen it once. Negative 19.8 squared. And that should work out to 21.6 meters per second. Then the theta, we'll do an inverse tangent. The opposite is, and it doesn't matter whether it's negative or positive, we'll just deal with the direction in a couple minutes, a couple seconds. The opposite is 19.8, the adjacent is 8.6. So that's about 2. And let's double check here. 66.5 degrees. And we say below the horizontal. And hopefully that was helpful in showing you what happens when you throw something straight off a cliff, or you drive something straight off a cliff, or roll a ball straight off a cliff. And of course, we'll have some problems to practice that. Take care.